kicks off. There we go. Bear with me just a second. Oh, come on, computer. Well, we'll go ahead and get started. I was going to show a slide, but my computer apparently doesn't want to do screen share right now. But welcome, everybody. This is the second meetup we've had this year where we're trying to get this group going again. So we're going to be doing a lot more of these. We have Vlad from AWS here. He was nice enough to jump in and help us tonight. And we've got another one already lined up for May called 60 Minutes to AWS Mastery, which that seems like an ambitious goal, but I'm interested to hear it. And then we've got somebody lined up for June, but I don't have the topic yet. As soon as I do, I'll put that event out there. So please definitely make sure to check out what we've got coming up. If you have any questions for me, again, my name is David Simonis. I'm a consultant with a company called SEI, but you can reach me on the meetup group. You can shoot me a message there. Feel free to reach out. If anybody's looking and has some career opportunities or is looking for some career assistance, feel free to shoot me a message as well. I'd love to help people find homes especially in the AWS space. So that's it. If you, again, reach out to me anytime. Love to know how to make this group better, more interactive, and how we can get as many people as possible involved and get the community really going again. So with that, I'm going to turn it over to Vlad. It's all yours, Vlad, and I'll let you share your screen. Excuse me, share your screen and kick us off. And again, if you guys have questions, feel free to raise your hand, post a question in the chat, or just speak up. I'm sure Vlad would love to answer any questions as we go.
Thank you very much, David. Hello, everyone. Thank you very much for attending this session, and welcome to the Everything You Wanted to Know About Kubernetes but Were Afraid to Ask session. My name is Vlad Hrybok, and I'm a Senior Partner Solutions Architect at AWS. I'm based here in Atlanta, and my background is in .NET software development and architecture, and my career spans many years in multiple industries. Today, I am happy to share with you basics of how to take any Linux-compatible application from running in a Docker container to running in a Kubernetes cluster on AWS. Hopefully everyone can see my screen, can hear me well. All's good?
All right, cool. Good from here.
Excellent, thanks. Hopefully the name of today's session didn't come across as too silly, but it was meant to be somewhat lighthearted and to serve as an acknowledgement that for many technologists, untangling Kubernetes value proposition and finding the happy path to the first success is sometimes unnecessarily challenging. This session is an introduction to Kubernetes in general and to Amazon Elastic Kubernetes Service, EKS, for developers, for operation folks, infrastructure engineers, DBAs, and other technical roles. Today's part of the session is a presentation where I walk you through the condensed Kubernetes crash course. After today's session, which is a part one of the two-part series, those of you with AWS Partner Central site credentials may access the video recording of the part two, a live coding demo showing deploying a tandem of two applications, the service and its client, to the EKS cluster by creating and running Kubernetes installation packages for our sample apps using a tool named Helm. At the end of the session, I will provide more details of how to access AWS Partners Central content and get access to the part two recording. Since I come from Windows background, some mental map ideas I will mention today may be based on common Windows features and properties, but they are not at all in depth, and I promise they will not cause any confusion for those of you using Macs. What's special about this presentation? The main goal of the session is to help you in building a mental map between what you already know from your existing experience and what is new and truly different in Kubernetes, while drawing on analogies in your everyday life, and also while clarifying overloaded and overused terms so frequently employed in Kubernetes. This session is mostly for those who are new to Kubernetes. If you are starting or started recently, you still maybe you're still likely to benefit from tuning in, listening, and watching. And if you are a seasoned Kubernetes expert, that probably will be a little bit boring for you. You probably know or guess that rolling out production-grade Kubernetes clusters on your own infrastructure is a very steep climb. AWS makes running Kubernetes cluster much easier, as evidenced by thousands of companies, large and small, preferring AWS for running their mission-critical Kubernetes workloads and making AWS a leader of the segment. Finally, whether you are dealing with a Linux application or Windows applications, you can host them on AWS EKS, and most everything you learn today will be applicable regardless whether your apps run on Linux or Windows containers, even though our examples focus on sample apps running in Linux containers. Here's my promise, which I think will make your time spent here worthwhile. After today, if you have any anxiety caused by unfamiliarity with Kubernetes, it will drop to very comfortable levels. You will be able to make sense of the Clinion-like vocabulary of Kubernetes. You should have no trouble having Kubernetes-centric conversation with customers and vendors. You will have good understanding of implementing Kubernetes for main use cases, including blue, green, and canary rollouts of your apps. You will see how Kubernetes lends itself for adoption by cloud infrastructure vendors. Most importantly, if you stick with me and stay focused through this pretty packed session, any other Kubernetes content you come across will be familiar and meaningful instead of disjoint and alien. So, I would like to ask you, could you please tell me if you're not familiar with basics of containerization at this point? I do have this kind of containers one-on-one slide that I can talk through, but if most of us are already familiar with containers, I would be happy to skip it. Please let me know how would you like to do this? Should we skip it? Should I talk through it?
Anybody want to speak up or at least post in chat?
All right, I'll try to go quickly through this slide. Okay, so the idea of containers, I found that there are tons of definitions of what containers are, what they're good at. I think for me personally, the easiest way to kind of grok what containers value proposition is that you can think of a container as an application binary execution unit with properties that are somewhere between a process and a virtual machine. So containers are very consistent. They have very high fidelity in replicating production environments. Kind of like virtual machines are. In virtual machine, if you have an image, you run a virtual machine. This image, wherever you start it will be pretty much the same. Very similar is with containers. This high fidelity is why we can finally say goodbye to the works on my machine syndrome that we often have when developers develop their software around test locally, deploy to production, just to find that it does not behave the way it was behaving on a development system. So installable package, a container image has all its dependencies, including operating system, but it's much smaller compared to virtual machine image, although they kind of similar in their consistency, because container images have this layer design, which makes sure that if you already have this layer already stored, you don't have to you will not have to store or upload it again when you try to run the container image. In terms of security, the isolation that containers provide is quite good. It's not exactly where the virtual machine isolation is, but it's definitely much better than the isolation of a process. So it's again closer in its security features. It's probably closer to virtual machine than to a process. They are lightweight. The starting of a container is they start really fast, sub-second in just milliseconds in most cases. And in this respect, containers are much closer to a process in terms of the cost of the start compared to virtual machines. And containers are kind of prepared to be running at scale, although not by themselves. They need additional tools for that. And if you come from Windows background, you can think of container images are like EXEs or like binaries, executable files, and container itself as a process. And just a quick note, image repositories, kind of like Docker Hub or Amazon Elastic Container Registries, they provide a way to store and manage your container images, almost kind of like application stores these days. So to kind of sum it up, developers enjoy easy life with containers after they throw the container-based tested code and the Docker file over the fence to DevOps and SRE, site reliability engineers and infrastructure engineers, because developers know that their code, once tested on the container locally, will work pretty much identically in production, and they don't have to worry about the works on my machine issue. Infrastructure engineers and DevOps also have their lives easier with containers, because finally they no longer have to be another level of QA for those lazy developers. They can just simply send the production logs to developers, and as bugs in productions are reliably reproducible in development environments. So containers run everywhere, from data centers to the cloud to laptops. They're lightweight and fungible, and they secure enough for most applications. So that's Containers 101. Hopefully that was enough for those of you who didn't get to containers yet. But having good understanding of containers is pretty important for Kubernetes, because Kubernetes, of course, is a tool that is called Container Orchestrator, and its main purpose is to run containers at scale. So to continue answering the question, what is Kubernetes and what does it do? Kubernetes and other container orchestrators make your containers cloud native by running lots of containers at scale. Kubernetes and other container orchestrators can host, scale, and resurrect your application containers if they crash, similar to how it's done by Windows services or Linux daemons. It's also helpful to think of Kubernetes as a data center scale operating system. Kubernetes is well-supported, open source, popular, and thus benefiting from the network effect, because lots of people contributing to improving Kubernetes, fixing, adding features, and providing docs. Kubernetes is designed to be adopted by multiple cloud infrastructure vendors via integration components known as custom resources. Kubernetes is built for integration with different infrastructure providers in mind. Kubernetes is adding an abstraction layer over the cloud vendors' compute, storage, and network infrastructure, helping customers who have a requirement to not depend on a particular cloud provider. Lots of tools and add-ons for Kubernetes are built by the open source community. For technologists with Windows background, I compare the journey from Docker to Kubernetes to going from running your web application on IIS Express to running them in IIS. And IIS has lots of features that you don't find in IIS Express. It has bindings and apples and sites, virtual directories, host processes, bitness and identities, certificate management, all of that stuff that you don't think of when you just launch your app in a tiny little IIS Express. You have to think of when you take your application to production, run it on IIS. So in this respect, running application in a single container relates to running application in Kubernetes pretty much on the same level. So Kubernetes is not for everyone. for the same reason why you're here. It's not trivial to master. That's probably its biggest issue. Kubernetes is vast, and it requires a fair amount of time to master, to learn and understand. It is also not free in terms that Kubernetes components consume your compute, storage, and network resources. Kubernetes is not the only game in town. For example, Amazon Elastic Container Service, ECS, although proprietary, is arguably noticeably easier to learn. It's well integrated with the rest of AWS services, and thus it is an attractive Kubernetes alternative for very many people. Finally, understanding Kubernetes vocabulary sometimes is just plain torture. Sailing, boats, all the seafaring ethos is the main theme for most of Kubernetes terms. Kubernetes itself is a Greek word, so if you happen to be somehow a Greek sailor, many Kubernetes terms will carry some natural connection. Otherwise, you have to put time into learning what they mean, and we'll start doing just that in a few minutes, because I doubt many of you grew up sailing in Greece, okay? Kubernetes is also fond of relying on very overused terms like service, control, or deployment. I love Kubernetes, but boy, do I hate their lingo. So please brace yourself. Building mind maps is what we will do today a lot, and that's what a lot of Kubernetes learning consists of. In an attempt to demystify Kubernetes as fast as possible, we'll start with taking a look at how we are going to interface with it using command line interface and GUI tools, so we can create some context before we dive into defining Kubernetes terms and concepts. So when dealing with Kubernetes, you will interface with it using following tools. kubectl. It is an open source command line interface tool for most things Kubernetes. It's probably the most important and the most frequently used thing. It's in some sense, it's a synonymous with Kubernetes. kubectl is where most of everything Kubernetes related starts. EKS is a convenience utility inspired by kubectl and used for managing AWS-specific Kubernetes infrastructure, like EKS clusters themselves, Fargate nodes, EC2 virtual machines, and for AWS-specific integration components. Next is Helm. Helm plays the role of the package manager and an installer for apps on Kubernetes. Next, many of interactions with Kubernetes involve infrastructure as code approach. To deploy containers to Kubernetes, one has to create a Kubernetes YAML manifest file that define your compute resources, define a desired final state, similar to, for example, Amazon CloudFormation, for those of you who are familiar with CloudFormation. Unlike CloudFormation, though, Kubernetes YAML specs are hard-coded and are not parameterized. Although we'll talk about it more, I need to underscore and repeat this point here one more time. The main way to tell Kubernetes cluster what to do is to send it a YAML manifest file describing your application's Kubernetes infrastructure desired final state. We will talk about it way more, but if you for some reason just need to drop off, go pick up your kids and I don't know, go to attend something, it's super important to understand that you create for anything Kubernetes, or for most things Kubernetes, you create a manifest file, you send it up to Kubernetes cluster through kubectl, and that YAML manifest defines the desired state in which you would like your Kubernetes system to end up. Helm takes Kubernetes hard-coded YAML manifest files and turns them into Go language templates with placeholders. These templates are known as Helm charts. Chart templates are parameterized manifest, very similar to CloudFormation. CDK is not yet GA, not yet released. It turns TypeScript, Java, or Python source code into parameterized Kubernetes YAML manifest, just like magic. So it implements same idea as Helm, only uses regular programming languages as a starting point rather than YAML. We will not use it today because it's not GA yet, but it's very promising, and probably, and if popularity of AWS CDK is of any indication of how much people prefer that to YAML, it's likely once released, it probably will be very competitive compared to Helm. If you prefer graphic user interface GUI tools, as I happen to do, Kubernetes can be installed on your good, powerful laptop with just clicking a box in a Docker desktop. This is just FYI, we will not use the feature today. You can almost replace using kubectl CLI tool with an outstanding Kubernetes plugin for Visual Studio Code. In my opinion, it's a must-have extension, and we will take a good look at it today. Open source Kubernetes web dashboard is useful, intuitive, and nice looking. It's very nice to have tool, highly recommended. I wish I could show it to you, but we probably won't have time for it. What we can do is take deploying Kubernetes dashboard to EKS cluster as a homework. You will have all the knowledge necessary to do it on your own. Right, looks like I need to speed up my pace a little bit. Okay, so as I mentioned a minute ago, the main way to interface Kubernetes is via Kubernetes YAML manifest files. Here I am showing 3 Kubernetes declarative YAML manifest file examples. It could be a single file containing all resources definition together, but it's customary to split them up. And this YAML manifest define how web app will be launched on an existing Kubernetes cluster from an image stored on the dockerhub.com. These files define a Kubernetes namespace, a deployment, and a service, all Kubernetes terms that we will define soon. For a quick reference, a deployment starts containers and resurrects them if they crash, as well as it moves containers between cluster node computers to better utilize resources, while Kubernetes services create a permanent HTTP endpoint for groups of containers where each container is meant to be ephemeral and disposable. An important core idea of Kubernetes is that Kubernetes deployment will spawn and destroy web app containers, while Kubernetes service will keep them network accessible at a persistent URL. Frankly, if from the whole session today, you remember only the part that Kubernetes deployments launch containers and keep them running, while Kubernetes services make containers apps accessible on the network, I feel I have earned my drink today. But there is quite a bit more, so let's stay focused and keep learning. Those Kubernetes manifests we just saw are uploaded to Kubernetes cluster using CLI kubectl apply command, which is arguably the most important and most commonly used command when dealing with Kubernetes. Multiple manifest files can be uploaded at once. No need to wait for one to be fully processed before asking to send another. Thanks for to the declarative nature of Kubernetes, we just specify what we want to have in the end and send the spec up. From that point, Kubernetes reconciliation loop routine will get busy and start creating resources, just like Amazon CloudFormation does when it builds out AWS resources you have specified in CloudFormation. Again, I pretty frequently come to the analogy with Amazon CloudFormation. For those of you who have some idea about AWS, Amazon CloudFormation is the way to build out Amazon AWS resources through the code, through the declarative statement encoded as YAML files. So it's very similar to how Kubernetes operates, and because of that, I will be pretty frequently referring CloudFormation, Amazon CloudFormation, as a reference or as an example. Okay, it's possible to use Kubernetes with the imperative model too, where you, instead of defining the desired final state, where you specify create, update, delete statements or commands. But using declarative style instead of imperative is just much more easy and is the best practice with Kubernetes. That's a standard way to do it. Again, you specify the desired final state and let the Kubernetes create, update, delete, whatever it needs to get you to the state that you specified, instead of you saying create this, delete this, update that. So that's again very similar to how Amazon CloudFormation works. To remove resources created by kubectl apply command, simply issue the kubectl delete -f and a file name with your manifest, and that command will, when launched against the same cluster, will clean up all the resources created in Kubernetes that were created through kubectl apply. Those of us with Windows background know that GUI is a faster way to navigate around your object model. Even if you now install Visual Studio Code, VS Code Kubernetes extension makes VS Code worth having it. I promise you. Even if you don't have it, just for the sake of simplifying your life with Kubernetes, go ahead, get VS Code and install Kubernetes extension into it. VS Code Kubernetes plugin is an excellent alternative to using Kubernetes CLI if you would rather use a GUI tool instead of CLI tool. More than 95% of what I usually do with kubectl CLI, I can do with point and click VS Code Kubernetes plugin more efficiently. I highly, highly recommend it. Another way to manage your Kubernetes resources or to monitor them is to use Kubernetes Web Dashboard. It's a well-maintained open source Kubernetes optional add-on, but really just another containerized web app running on your Kubernetes cluster. It needs to be installed manually using kubectl Helm, plus a few AWS CLI commands to run it on Amazon EKS. Returning login information, login authentication token can be a little bit of a nuisance, but not a deal breaker. The bottom line, a few minutes spent on getting it running, installed and running, we will pay you back handsomely in convenience and efficiency. This tool, like the VS Code and its Kubernetes plugin, is an excellent alternative to using kubectl CLI for many cluster management and monitoring tasks. No external tools like VS Code are required for the web dashboard if you decide to use it. To continue the theme of Kubernetes basics, once a container with your web app is started on Kubernetes via a deployment and is listening into inbound requests via Kubernetes service, you gain a number of options with how to access the web app in your browser. In development, while working on a local box on your laptop, you're most likely to use localhost port forwarding and Kubernetes proxy features. Both are functions of the kubectl CLI and VS Code Kubernetes plugin that do some magic, allowing localhost-based URLs on your laptop to route the traffic to an EKS or another remote Kubernetes cluster running on AWS or in someplace else. Using port forwarding results in shorter URLs, but has some drawbacks we'll mention probably a bit later. In production, where your web app needs a real internet-facing endpoint, you're likely to use techniques like load balancer type of Kubernetes service and Kubernetes ingress resource, all of which are Kubernetes constructs created specifically for integration with underlying infrastructure. Don't worry about what those load balancer services and ingress resources are. We are going to get to them in a few minutes. To wrap up the how Kubernetes is, how we interface with it, the final part here is, once you have an application running, once you ran your port forward command to access it from your local browser, this is effectively how it looks like. A container app shown here is running on AWS EKS Kubernetes cluster while you are accessing it from your development laptop browser at localhost. After using kubectl command to forward one of the local host ports to a remote Kubernetes container running a web application. Now that we have established that interfacing with Kubernetes can be done by anybody, it's not that hard or scary, let's spend some time learning about most important Kubernetes resource types, and also we'll work on making sense of Kubernetes lingo. I have already used terms like namespace, deployment, service, ingress, and a few others. Hopefully they were relatable enough from the context of what we're talking about, but if not, we'll dissect them and demystify them right away. Okay, here I'm going to commit presenter's cardinal sin and speed read the slides bullet points. The reason for that is each bullet here is a bumper sticker size definition of a Kubernetes resource that you will likely have to create, use, or manage when dealing with Kubernetes. There is no way around it, and I would like this concept to be planted in your minds very firmly through both seeing and hearing. Okay. So let us go. So what is node in Kubernetes? In Kubernetes, node is a virtual machine or a computer running either your containers or pieces of Kubernetes software. Kubernetes cluster is a collection of multiple related nodes, which are, of course, VMs, computers. The concept of namespace. A namespace is a logical construct that defines a naming, security, and resource limit boundary. For example, if you name a service ABC, it has to be unique within the namespace. But if you have multiple namespaces, you can deploy multiple services named ABC to different namespaces. Pod is one or more containers sharing local host and interprocess communication channels, and all of those containers will have to be deployed as a single unit. So roughly pod is almost like a container, can be more than one though. Deployment, which we already mentioned today, is a running collection of long-lived or quasi-permanent pods started from a single image. In most cases, deployments run your web application containers. Service is a stable, permanent network endpoint for a group of pods with matching labels. Effectively, service provides an HTTP endpoint through which your application containers can be reached. Label is a text moniker grouping related Kubernetes resources together. We'll talk about labels a little more, but you can think of a label as a foreign key if you are a database guy that creates relationships between otherwise unrelated Kubernetes resources. Ingress is a configurable and routable external endpoint, external network endpoint serving one or more services. Effectively, it's a way to let your traffic in from outside the cluster into your Kubernetes cluster. Config map is a structured data accessible to pods via either environment variables or mounted volumes. Very similar are secrets. They are base 64 encoded data pieces accessible to pods either via environment variables or mounted volumes. Persistent volume is pretty self-explanatory. It's a long-lived file storage shared between containers, and even if containers dies and resurrects, the information stored persistent volume continues on. Jobs and cron jobs, kind of similar to deployments because it's another type of a workload. They're short-lived batch and start-to-finish workloads, where the deployment is a long-lived, kind of almost permanent type of workload. Jobs and cron jobs are batch workload that start to finish and disappear. And cron means they're scheduled, run on schedule. And the customer resources, they are third-party components exposed as Kubernetes resources. This is one of the strongest things. Kubernetes is very extensible. You can create extensions for Kubernetes, and when you create them, you can make them look to outside world, to users, as native Kubernetes resources. So now let me define most fundamental and most frequently used Kubernetes resources types that we just described in a bit more detail. Guys, I realize this is pretty dry, and I probably at the end of the day you're struggling, or maybe it's kind of packed and intense. But here's what I would like to suggest here in the middle of this session is that if you kind of stick with me, if you go through this, if you focus, even if it's hard to understand right now, I promise you, once you start reading more about Kubernetes, you will come across these terms a lot of times. And in many other places, they are kind of disjointed. They are taken with the assumption that you understand a lot of context. So this session is what I wish somebody told me when I just started learning Kubernetes. So I am packing here all the most important information. So if you stick with me, if you stay alert, I promise you that even though it may be a little bit dry and difficult, it probably will save you a ton of time and frustration later on when you read other sources, watch videos. A lot of things that otherwise would be very alien will be much more familiar to you if you continue to pay attention what I'm talking about here. So of those things that I just listed, we'll have to focus on a few of them in a little bit more detail. So starting with something relatively simple and straightforward. A cluster consists of nodes, as I mentioned, where nodes are computers. They could be either virtual machines or true bare metal computers. Some nodes run your workloads. Those are worker nodes, and they form Kubernetes data plane, while other nodes run software that manages the cluster. Those nodes comprise Kubernetes control plane. Worker node computers could be running either Windows or Linux, enabling both legacy Windows and Linux cross-platform apps to run on Kubernetes. With Amazon EKS, we never have access as users to control plane nodes, which is a good thing. We don't have to maintain it. We don't have to pay for them. That's the AWS's burden. Worker nodes will show up in your AWS console as regular EC2 virtual machine instances unless you run EKS exclusively on Fargate. And Fargate is a serverless compute substrates. It's a set of VMs that do not show up in your list of virtual machines. So if you run your EKS fully on Fargate, which is possible for Linux containers, in that case, you will not have access to the data plane nodes either, making your EKS cluster totally serverless, alleviating the burden of having to patch them, to maintain them, and so on. Your containers get assigned to nodes by Kubernetes implicitly based on container specs describing amount of CPU and RAM required for the app. The number of nodes in the cluster may vary depending on cluster scaling settings and whether your containers are assigned to Fargate nodes or to regular virtual machines. Multiple pods can run on the regular EC2 worker node, while in the case of Fargate, a new Fargate node is launched for each pod, resulting in one pod per Fargate node. So next things that we'll look at are namespaces and pods. Kubernetes workloads run inside namespaces, which serve as logical resource limit and access boundaries within the cluster. Here we see three namespaces, each hosting their own set of Kubernetes resources. The most important implication of having a namespace is that only one service with a given name, like my service, may exist within a namespace. This makes it possible for a client container to call my service at a URI that is as simple as HTTP my service, which is very, very simple and cool, I think. Cross namespace URLs are also permanent and have specific name formats. That makes service discovery inside a cluster a very, very easy proposition. Pods are sets of tightly coupled containers that could be deployed as a single unit. or have to be deployed as a single unit. In most, but not all cases, a pod has only one container. If you start your Kubernetes journey thinking pod equals container, you'll be just fine. Pods are ephemeral in a sense that any pod may go away, it may crash or be scaled in by Kubernetes, and its replacement pod will likely not get its original IP address. Therefore, although it's possible to start just a pod in Kubernetes, for example, you can use kubectl command to start a pod instead of start a deployment, for example, it's not practical, and other Kubernetes resources exist to offer abstraction layers shielding us from the fleeting nature of pods. Let's see what those resources are. Of course, it's a deployment. Deployment is one of the worst named Kubernetes entities, I think. When you define a deployment in the manifest, you specify how many container instances need to be started from a given container image and what labels to assign to those containers. If a container crashes, the deployment will start another container from the same image. Deployment is also a vehicle for scaling your containers. Well, technically, there is a little bit more, there is an asterisk to that statement, but for simplicity's sake, you can think of deployment as a scaling mechanism for containers. So if a standalone pod running on its own is kind of like a program started on the computer, meaning once it crashes, it's gone, then a deployment is very roughly like I said, it's like a Linux daemon or a Windows service, which can be configured to resurrect your program after it has crashed. Deployments let Kubernetes schedule and maintain running application containers. As you probably realize by now, Kubernetes deployment is pretty much where you start when creating your Kubernetes YAML manifest for deploying your applications on Kubernetes. That's because the main input for the deployment is a Docker image URI pointing to an image registry like Amazon Elastic Container Registry or Docker Hub. The output is one or more pods running on and managed by Kubernetes. Here you see that the deployment tells Kubernetes to pull the image name docker-2048 from the Docker Hub. Docker Hub is implicit here, for example, if image does not specify image repository location, where here you see it just specify contain image name. It means that it's in a Docker Hub. A fully qualified URI could be used instead. This manifest also states that 5 pod replicas should be launched when that pod, and that the pod should get the app label with 2048 value. When we take this manifest file and send it to Kubernetes by running kubectl apply -f command, Kubernetes will schedule 5 pods on as many cluster nodes as allowed by cluster configuration. There are a few other settings that you will likely define for a real-life application when creating the deployment manifest. Those include RAM and CPU requirements, health probes, etc. A pro tip: when it comes to health probes, they are named readiness and liveness probes. For me, it was hard to map in my mind how is liveness probe different from the readiness probe. The secret here is to simply twist it and kind of flip it upside down to think of liveness probe as of deadness probe. Its goal is to take Kubernetes when the pod goes unresponsive, so it should be killed and get restarted. All right, next we'll demystify the Kubernetes service resource. Service is a term that is so overloaded and overused that it is virtually meaningless unless explained within a given context. So in Kubernetes context, the service is a purely networking construct. It's a stable network endpoint, HTTP or HTTPS in most cases, starting with a cluster scoped unique permanent IP address through which a collection of pods grouped by the common set of labels can be accessed. In the simplest case, a service is a persistent HTTP endpoint, a URL, pointing to a collection of one or more pods whose IP addresses are dynamic. For a more complex example, please take a look at this slide. There are two deployments, each running one pod of specific application version 1, version 2 respectively. These two versions are backward compatible and can respond on the same HTTP endpoint. If you can map it in your mind to think of a Kubernetes service as a virtual IP or virtual load balancer for pods living inside a namespace, you'll do just fine. Next is a label. Labels are very important things in Kubernetes. They are much more than just a tag. Labels establish grouping and relationships between Kubernetes entities. For example, a deployment, when it launches a pod, will assign one more labels to the pod in accordance with the spec defined in the deployment manifest. Then the deployment will periodically check how many pods with that set of labels are up and running. If it finds a fewer number of running pods than specified, the deployment will launch additional pods, or conversely scale pods in if the desired number of pod replicas was reduced. Same with services. A service knows its pods only by labels mentioned in a spec. This way, the same pod can be accessed via multiple services. The diagram on the slide flows from right to left. It starts with two Kubernetes deployments, each spawning a single pod, which is specific service application version. One launches service version 1 and another runs service app version 2. We end up with two pods, one for each of those two service application versions. Please note that each deployment assigns two labels to each application container. The app label value does not change. It's the same. It's shared between both versions, and it stays set as my SVC app. The app ver label does change with each release, so both containers end up sharing app label value while having distinct app ver label values. When Kubernetes service is defined, spec selector labels are key to telling the service to which container it will be sending requests. On this diagram, we created three services. Two of them are version specific, and these services create version specific HTTP endpoints useful for validation and testing. The service in the middle on the left side has its label selector set to point to any container, to all containers that have app label set to my SVC app value, which will result in requests sent to HTTP my service endpoint being forwarded to either version 1 or version 2 containers in a pseudo-random fashion. Using Kubernetes services with version agnostic label selectors enables creation of canary and blue-green version rollout models for production services. I hope you guys can appreciate the power of it. So you have two containers, and yet you have three different endpoints to access them. A couple of endpoints that are specific to versions, and one endpoint that kind of rotates the traffic between each of those. That is very cool and opens a lot of use cases. One last important note here, I frequently see a very questionable pattern where applications deployed to Kubernetes have one-to-one relationship between their deployments and services, while labels allow much more flexible many-to-many relationships. It's very important to realize that the relationship between Kubernetes deployments and services is mediated by pod labels only, and those are serving as an indirect link between those two types of resources, enabling very creative application rollout and rollback scenarios. And here we'll talk a bit about the second most important facet of a Kubernetes service. Specifically, we'll talk about different ways to access your Kubernetes service from inside and outside the cluster. And as I mentioned earlier, at the very least, Kubernetes service allocates a permanent IP address valid inside the cluster as an endpoint through which traffic could be sent randomly to a group of pods that share a given selector label or a combination of selector labels for the service. That inner cluster IP is mapped to a domain name matching service name. Knowing that IP or DNS, any caller within the namespace can call the service simply by the very simple URL that is HTTP service name and port number, which is optional. That URL, of course, is very simple for clients to know. Service discovery hardly gets any better than this. Even if the caller lives in another namespace, it can still access the service by the combination of the service name and the namespace name. As it's shown on the slide, the second URL here shows how you call the service from another namespace. So when discussing Kubernetes services, we have to talk about service types, unfortunately. That's another thing that is kind of dry, but we have to talk about it because you will come across it a lot. So cluster IP is an internal access, allows us to access services, Kubernetes services, only from inside the cluster. It effectively gives a cluster-wide IP address to your service. That IP stays the same. Your pods that are hidden behind this service endpoint, they can come and go. Their IP addresses will change, but this cluster IP will not. But this cluster IP is, by the way, the term again is terrible. It should be called something like internal IP, not the cluster IP, because this is IP that is scoped to the cluster and accessible from inside the cluster. Next type of the service is node port. A node port is a type of the service that is kind of sort of accessible from outside the cluster. You can actually do that by assigning a port to the service, and if you know any IP address of any cluster node, you can effectively build a URL which consists of the node IP and the port that you assign to your service, and those together will provide the access to your service from outside the cluster, which this way is kind of cumbersome because first, in order to do that, you need to know the IP addresses of your nodes. So you kind of need to maintain a list of nodes, and nodes themselves are kind of mortal. They can go scale in and scale out. So that's not how usually I'm listing node port here, but it's not how you typically access your services from outside. Node port is mostly used by third-party integration components. There are two ways how you usually typically access your service from outside the cluster. It's either through load balancer service type or through ingress resource, which is not a service, it's a separate resource, but since it serves the purpose of providing external visibility to Kubernetes services, I included it here. So what is load balancer? Load balancer service type, and by the way, I should have said that service type, again, is a terrible, terrible nomenclature. You can think of service type is so generic that it's borderline meaningless. So you need to think of service access type instead of service type. So anytime you see a Kubernetes service type replaced in your mind with Kubernetes service access type, and you'll be much better off. So service access type set to load balancer, what it will do, it will rely on your integration components, on your cloud vendor integration to create an external load balancer, which is probably specific to your infrastructure. In AWS, it will be AWS load balancer that will be sending traffic to your service. When your cluster is set up correctly, this is a super easy way to just expose your service not just outside the cluster, but on the internet as well. You just basically create a service, give it the load balancer service type, and a few minutes later you have a AWS load balancer that is accessible on the internet and sending traffic to your service in the Kubernetes cluster. However, it has a little bit of a downside. Load balancers are not exactly super cheap. And if you have a load balancer created per service, especially if you have a microservice design and architecture, having lots of load balancer will probably add up to a build that you may dislike. So to reuse load balancers, to reuse a single load balancer to provide external access to multiple of your Kubernetes services, it's common to use ingress resource. An ingress resource is effectively a component that allows you to reuse an external load balancer like ALB, Amazon Application Load Balancer, to share it, to send the traffic to different destinations within the cluster. So ingress is what allows you to be more efficient and cost-effective when exposing your services outside the cluster, especially on the internet. All right, good. So the reason we have dwelled on pods, deployments, services, labels, and ingress this long is because those are resources that you are likely to deal with the most. And understanding what they are and how they relate to one another is absolutely crucial for quick adoption of Kubernetes. Other resource types are more intuitive. So let's quickly walk through the remainder of them. I promise I'll make it as fast and as painless as I possibly can. So a config map, again, to reiterate, is a place to share non-sensitive application configuration settings data with pods. Config maps are either mounted as read-only volumes accessible to containers on each pod as files, or used as values for container environment variables. For example, an application configuration settings file would be a good candidate for the type of data to be stored as a config map. When data in the config map is updated, container-mounted volumes get the updated version of the data as an updated file. Secrets are base64 encoded data chunks very similar to config maps. It is also accessible to containers app either as files or on mounted volumes or as environment variables. Secrets work better for storing passwords, keys, and other sensitive types of information. Since base64 encoding is not really an encryption, please keep in mind and be sure to use Kubernetes role-based access control, RBAC, to make sure secrets are accessible only to appropriate security principles. We'll touch on Kubernetes RBAC role-based access control in just a few minutes. Persistent volumes is something that should be pretty self-explanatory. It's a mounted read-write file storage where data survives if pod goes away and comes back later. Job and cron jobs are workloads similar to deployments, but unlike deployments, which define long-running service applications, jobs are batch process running from start to finish. And cron job is kind of a job that is scheduled to run periodically. Custom resources is an extension mechanism for Kubernetes. Third-party add-ons can be implemented as custom resources. Sometimes you will hear about installing CRDs, where CRD stands for Custom Resource Definitions, which specify how custom extensions get added to the Kubernetes cluster and get exposed via standard Kubernetes APIs and tools. There are a few other resource types not mentioned here, but I think I tortured you enough. However, our goal here is to cover the most frequently used resource kinds and shorten your learning curve as much as possible. From this point in our session, the going should get easier So thank you for sticking with me through this very important, although somewhat difficult and dry part. Okay, now that you're equipped with understanding of what is what in Kubernetes world, let's spend a few seconds looking at the Visual Studio Kubernetes plugin, how it sees a Kubernetes cluster, as well as look at the Kubernetes dashboard, web dashboard view, and see all the resource types we just learned. You probably have noticed that there is still a handful of resources we have not mentioned, like daemon sets and replica sets and replication controllers and stuff like that. Don't worry about those. Like I said, I already saturated you enough, and we focus on things that you're most likely to be dealing with in real life, in your day-to-day life, if you start working with Kubernetes on daily basis. So here you can see, for example, in the Visual Studio Code plugin, you can see your namespaces here, and you can have namespaces here in Kubernetes dashboard. You can see nodes link, and you can see a nodes link here in Kubernetes dashboard as well. You can see services here, and you can see services here as well. Same goes for ingress and ingress here. So as you can see, both of these monitoring and management tools, they are exposing these things that we just learned, so that we could all go and navigate and see what's going on and use these tools effectively. Also, please note that in the middle of the screen, there is a snippet of YAML defining a service. You probably see on line 2, it says kind service right here. That's how, by the way, a resource definition YAML manifests are created for Kubernetes. You create a YAML file, declare the type of the resource you are specifying, and proceed to set property values specific to the type of the resource you're dealing with. Those of you who are familiar with Amazon CloudFormation will see very clear parallels here. This picture should make sense for you now. I hope it does. If it doesn't, we'll have to go back to the previous slide, go through it again, and commit it to memory until we can recite it by heart. Jokes aside, though, firm grasp of the main Kubernetes terms is a milestone that should not be neglected. And congratulations, guys, to going through this. We are not going to spend a lot of time here on role-based access control for Kubernetes, mainly because, thankfully, mercifully, even though role-based access control in Kubernetes is quite important to understand, fortunately, it's pretty easy to understand intuitively. Thankfully, Kubernetes did not mess up terminology here. They didn't call it anything related to I don't know, driving ships on the sea. They just call it what it is. Role-based access control is exactly what it sounds like. Roles define sets of permissions, and role bindings attach roles to specific security principle known in Kubernetes as subjects. Again, here you'll have to make a little bit of a mental map. So subjects are what we used to call principles in the rest of programming life, which includes users, groups, or most frequently in practice service accounts. There is no way to deny permission. They are denied by default and are granted explicitly. There are two types of Kubernetes roles: regular roles, which are scoped to a namespace and represent namespace scope permission sets, and cluster roles, a cluster scope permission sets. Both roles and cluster roles define permissions as shown on the slide in the top left corner. There are also predefined roles and cluster roles in Kubernetes, the Kubernetes call them default roles and cluster roles. Some of them are like cluster-admin, admin, view, edit. So those are roles and cluster roles that come by default. To tie subjects to roles, Kubernetes gives us role bindings and cluster role bindings resources. Those are pretty self-explanatory. You can see how a role binding is defined on the slide in the middle. So you can see it simply binds a role to either a user or a service account, and that's what role bindings are. Again, thankfully, I don't have to do a lot of dog and pony show. Fortunately, it is straightforward. Well, Kubernetes would not be itself without Helm. We have to talk about Helm, as within the Kubernetes ecosystem, it is one of the main tools, one of the tools that you are likely to use from the very beginning, and the tool that I recommend that you start using from the very beginning. It is as important to Kubernetes as NPM is important for Node.js development, Maven for Java programmers, and NuGet for .NET engineers. I really like Helm, and I use it as a default option instead of straight up Kubernetes manifest, but I personally think that Helm is, again, terribly meaningless name, yet there is nothing I can do about it. We'll have to stick with it. Helm is a package manager, which is technically correct, but unlike the Docker Hub or NuGet.org or npmjs.com, there is no dominant or preferred public Helm package repository. In most cases, you create the package. By the way, Helm packages are called charts, another eye roll for those seeking clarity in naming. And after creating a package, the chart, you feed it to Helm CLI to install the app on Kubernetes. So you will be creating Helm charts, which in turn mean creating a set of text template files, mostly YAML again, stored in a predefined folder structure prescribed by Helm or in compressed archive file. You may ask, why do I need Helm at all if it looks like we could just use Kubernetes YAML manifest files to install apps by running kube apply -f file name? That's of course true. The only difference is that Kubernetes YAML manifests are all hard-coded. Straight up Kubernetes YAML manifests are not parameterized. Whatever you put in there is in there, period. With Helm, you can parameterize your manifests. Helm uses Go language templates with placeholders to create parameterized versions of Kubernetes YAML manifests. Think of your Helm charts as Kubernetes manifests with placeholders that can be filled in with values supplied at the installation time. In fact, when you run Helm install, it actually produces a regular Kubernetes YAML manifest with all values plugged in into the placeholders and send them to the Kubernetes fully baked. You can actually see Kubernetes manifest generated by Helm if you run Helm install command with a --dry-run argument. So dry run is an argument that allows you, instead of doing actual Helm install, it will generate the YAML manifest, the final version of it that is actually sent to Kubernetes. One more additional thing that Helm does is it keeps track of groups of resources created during installation by creating releases. Releases are entities tracking all resources deployed by the Helm install command. This way, it's very easy to undo Kubernetes Helm installation by rolling back a release. So instead of deleting your resources one by one, you just say Helm delete and give it the name of the release, and that's it. It's deleted. Super easy, super convenient. It makes it so much easier to stand up and tear down your Kubernetes resources. The slide here shows the difference between a regular Kubernetes YAML manifest and the same manifest in the Helm chart format. On the right, you can see template value placeholders between double curly braces. If you ever created an MSI installer for Windows application, you know that the installation will have some parameters with default values. For example, a default target installation directory, which can be changed during installation itself. Helm is similar in that it also has a way to supply default values for all the placeholders and a way to override those defaults at the installation time. Just like with Windows MSI installer, creating an installer can be very simple or quite involved. And just like with an installer, it's easy to start small with Helm and continue on building very sophisticated application installers. Although I am not a fan of the name of the tool, Helm is very useful in creating Helm charts instead of a regular Kubernetes manifest, should be your default choice and practice whenever possible. To jump a bit ahead, the live coding demo session will not rely on hard-coded YAML manifest, and instead it jumps straight into creating Helm charts and installing the application with Helm. One final point here is, if you're not a fan of YAML, there is a new up-and-coming open source tool that is based on components and technology developed for AWS CDK, Cloud Development Kit, which generates Kubernetes YAML manifests from the code written in normal programming languages like TypeScript, Python, and Java. The tool is called CDKs, and its concept is similar to Helm in that it is parameterized, and it produces Kubernetes YAML as an output while taking Kubernetes resource definition expressed as classes written in regular programming languages. We are almost done. I've got just a couple more slides left. So here's the cliffhanger for the next session. In our part 2 of this series, I live demo the creation of Kubernetes installers for 2 ASP.NET cross-platform Linux compatible applications, a Color service and a Color client. In that demo, I use Visual Studio to generate Helm charts, Kubernetes installers for each of the 2 applications, and I use Helm install command to deploy applications to AWS EKS Fargate serverless Kubernetes cluster. I also show how the EKS cluster was created prior to the session start, which is very easy to do. You just use a small CLI command. That is all it takes to create a Kubernetes cluster on AWS. The catch is that the part 2 session is a video recording available only to AWS partner companies and their employees. So before wrapping up the session, I would like to mention that I am, as a partner solution architect at AWS, my primary goal is to help AWS partners helping their customers. Being partner focused means that I would like to ensure that all of you are aware that partnership with AWS brings lots of advantages to both partners themselves and their customers. If your company is a partner or decides to become an AWS partner, you can access the recording of the part 2 of this series, where I live code creation of the Kubernetes installers, Helm charts for 2 related web apps, and use these installers to deploy the application to AWS Kubernetes, Elastic Kubernetes Services cluster. If you work for a big company, chances are your company is already an AWS partner, and you should have access to the second part of this series. For companies that are already AWS partners, when you create an account at the Partner Central website, which is a portal for AWS partners, you should be able to use your corporate email address to be able to access Partner Central resources. If you are not sure whether your company is an AWS partner, please try to locate a person within your organization who is your company's AWS Alliance lead to verify it's all right to create your Partner Central account. In most cases, it's fine. The only thing I worry about, if you work for some huge company and that company somehow is not yet an AWS partner, you go ahead and register your company as AWS partner. Your CTO may be unaware of it, may be a little bit upset. So in most cases, the big companies are already AWS partners, but if you're not sure, make sure that it's all right to create a Partner Central account and access the recording of the live coding demo. Well, with that, I would like to mention one more thing. Even though I didn't write this book, I highly recommend it. It is very concise, less than 200 pages, very to the point, with just right amount of detail. If you want to understand ins and outs of Kubernetes, in my opinion, this book will get you there fastest. I saw a lot of sources, I read a lot of articles, I browsed tons of pages, and I got to tell you, this 193 pages worth every penny and every minute you spend on it. Excellent, excellent book, and the shortest path to Kubernetes outside of this session. I would like to thank you very much and thank David for the opportunity to speak to you today. David, if you could paste those links that I provided, thank you if you already have. I really need to ask you a favor of please clicking on the feedback link and tell me how horrible I was today, how much I annoyed you, how difficult the material was. Tell me all of that. But if tomorrow you wake up and read another blog article about AWS, and all of a sudden all those lingo come back to you and you know what they're talking about, I will be happy to take all the abuse in the feedback form that you mastered to throw at me. If you would like to drop me a line personally, my email address is on the screen and also in the links that David posted. Again, thank you very much. I really appreciate your time. Thank you for being interested in AWS stuff. It's super cool. I cannot get enough of it. Regardless of the background you come from, this is an awesome set of tools. And if you have questions, I will be happy to answer them. Feel free to just unmute yourself and ask them, or if you are shy, please. So,
Chandra, I put the link to the Kubernetes book in the chat. If you want to look up there, you should be able to find it.
The name of the book is very easy. It's called the Kubernetes book.
And I'll put all those links on the meetup group as well in the comments for the event. But Vlad, I'm pretty sure this all was just a giant tease to the second part of the video, recorded video, because that's, I think, what I really want to go out and see. So.
Yes, so I highly encourage you guys to figure out how to use. That's exactly the catch here. I want you guys to figure out how to use AWS Partner Central website, how to know that you are already a partner, how to maybe see a few things that catch your eye about the benefits of being an AWS partner. And once you're there, watch that video. And that video will give you hands-on idea. It uses a Visual Studio, but frankly, because .NET is cross-platform for many years now, it is just like Python or TypeScript or whatever else. It's just another Linux-compatible development system. And I will generate there. I use some shortcuts to general installer for Kubernetes and install app. You will see how easy it is, how easy to create a cluster, EKS cluster on AWS. If you ever try to create an EKS cluster by yourself, you will definitely appreciate that how incredibly easy it is to create on AWS instead.
Sure, I think we've got one question. Somebody's got their hand raised.
Yes, so this is Tapas here, Vlad and David. Thank you for this session. It was very informative and
sure.
So much.
Sure.
Would you be sharing this presentation with us, or how do I get the links? Like in the session 2, my organization is already a partner, and I want to go ahead with these exploring the links that that is shared. So.
The links are in the chat for this meeting, but I will go post them right now on the meetup page. If you go to the event,
okay.
In the comments there, I will post all these links again as well. Once the video recording is done, I will post them in the comments, the link to the video for today's session in the comments for the event as well.
Sure, that would be great. Thank you so much, Ian. So I look forward to attend this kind of sessions in future as well. And thank you, Vlad, for your wonderful.
Oh, absolutely. Anytime, guys. Thank you for joining, and special thanks to David for resurrecting the AWS Atlanta AWS meetup. It's awesome once everyone gets their COVID vaccinations. I'm sure we all get together again and share pizza and some beverages and see each other in person and talk. We are all tired of the screens and webcams.
Yeah, I couldn't agree more. Hopefully we'll be able to do that soon. I'm planning on having meetings that we can maybe do in person and online for those that aren't quite comfortable yet meeting in person. So just keep an eye out for that. I'm just not sure if we're going to do it the next event, the event after, but hopefully soon. And I'm trying to line up a sponsor as well for that. So we'll get that figured out. If you guys do have any feedback for me, though, feel free to email myself either via the meetup page, or I just put my email in the chat as well. Looking for any feedback on how we can improve the group, what resources you guys want or need, and we can go from there. Did anybody else have any more questions for Vlad today? I'm sure he'd be happy to answer any questions. Okay. Well, I did post all the links in the comments on the meetup on the event page. And again, once the recording's available, I'll put the link out there as well. And thank you again, Vlad. I really appreciate it. Again, I mentioned it at the beginning, but for those that didn't hear it, the topic for May is 60 Minutes to AWS Mastery. A gentleman by the name of Daniel Brown will be presenting that one, and we've got somebody lined up for June, and I'll be posting that event soon as well. So thank you, everybody, for attending, and thanks again, Vlad. And once again, any last questions, feel free. Otherwise, everybody have a great night.
Thank you, David. Thank you, Vlad.
Thank you.
Thank you, everybody. Talk to you later. Bye-bye.
Bye-bye.